So
Yes, sir, you
today
gave us
we're
a question for homework. उसमें ग्राफ
sorry,
बनाना था वो वाला नहीं होया. You gave us a question for homework. उसमें ग्राफ बनाना था वो नहीं होया. Yeah, this one.
this one or that one?
No, the other one.
Okay, the other one. All right, let's do that first and then we'll move to this. So first of all, they have given you
No, sir, the
okay,
graph part only.
okay, I'll do that. I'll do that. Don't worry. So first of all, I would like to tell you that this section at 0 it is 0, so speed will also be 0. If you go here, put a dot here. Then when it reaches this point, which I believe is 1 second. No, it is 1 point. What is that? 1.1. So it reaches a speed, a velocity of, I don't know what that is. 10.8 maybe, right? So you go to 1.1 on this right here. Go to 10.8 and make the straight line like that. Okay. Then okay. Then when you see this line, okay. Now there's something you got to do here, a bit of change. So the speed becomes 0 till this point, and then it becomes -8.8. But then it starts from this point, which is like one whole, like one box after. Okay, so what you're gonna do? So from here till here, you're gonna make the speed 0, and now you're gonna rise this back to 8.8, which is here. Why? The reason you need to do this is because speed is a scalar quantity, and you are just going to look at the magnitudes, not the direction. Finally, from 8.8, you got to go 0 in about 2.1 second. So you go to 2.1 and then go 0, straight line. And then the same cycle repeats, where you got to go from here till 8.8 again. So you go here. And what time is that? That's exactly at 3. So you go at 8.8 like this and draw a line like that. Is that clear? So basically what you're doing is you're only going to shift, the whole graph is same. You're only going to shift this section of the previous graph upwards like this. Is it clear? Take the graph out, please.
Yes, sir.
All right. Now, can I go forward now to projectiles, please?
Yes.
Okay, cool. So, projectiles then. So, what's gonna happen is that who's missing today? Let me just quickly check. Javeria is not here, you know? All right, never mind. Okay. For projectiles, I just want to tell you that projectile means basically two dimensional motion. Now, obviously, when something goes like this, originally, what should happen is if you throw something here, it should keep on going in this direction. That doesn't happen. The reason is that this vector has two vectors, one like that, one like this. So this is next to the angle. So this is u cosine of theta, and the other one is u sine of theta. So Then what happens is that the acceleration due to gravity is always down. So the vertical component keeps on changing, which means if I take a couple of points like this one, and the top one, and then this one, and this one. So basically, it keeps on decreasing its magnitude. And then here, u sine theta is 0. And then when it becomes 0, it keeps on increasing because now it is falling down. And at the end, it is the highest anyway. But what you guys need to understand is, although the vertical velocity keeps on changing, the horizontal never changes. So at this point, or 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 even this point, the horizontal never changes. It stays the same. Okay. So in any case, if the examiner asks you that which point on a projectile kinetic energy is 0, so you say none. Because the thing is that although the vertical velocity changes, horizontal stays constant. So you should always remember this and answer it like this because that's the truth. All right. Now, speaking of this, then, I also want to basically tell you that if you just follow what I'm going to tell you right now, you will never get a projectile question wrong. So for horizontal, you will need only three quantities. You will need displacement, which is t. Okay, that's right. And that displacement is basically this horizontal displacement, d. You need velocity, which is v, and you need time, just t. Horizontal velocity is the component. In this case, it is obviously u cosine theta. And only one formula, and that is velocity is equal to displacement over time. And that's the only formula you're going to use for horizontal, finding anything horizontal. Okay. Interestingly, there is no connection between horizontal and vertical except for one thing. So you need SUVAT here. In this one, displacement is the vertical one, wherever it is. So it would be y. Initial velocity will be u sine of theta. And final velocity is, it could be anything really, but it would be, let me just write it here, will be 0 at maximum height. So you will remember that. Acceleration is basically 9.81 plus or minus depending on where velocity is. If the velocity, like I told you in the vertical, you know, vertical motion as well, if the velocity and the acceleration are in the same direction, you take the acceleration as positive, otherwise you take it negative. Anyway, and obviously this is time t. Now, the only connection that I was talking about between vertical and horizontal is this connection, which is time. Because time is independent. which means that when it is going to go up or down, it is also going to go forward. So at each point, wherever it is, the time for the horizontal and vertical would be the same. So you guys can always rely on that. Now, for vertical, you're going to use the three equations that we know, which is S equals to UT plus half AT squared. 2as equals to v squared minus u squared. This is the most common equation in the questions. And obviously, v equals to u plus at.
Sir,
Yes.
sir,
Yes,
for A, what did you write?
for a what? Where?
Just now you were writing.
I just said that, oh my
Plus minus
goodness.
9.81 depends on.
Depends on the direction of velocity.
Okay.
Okay. So if the velocity, this is the same as what we've done in, um, vertical velocity. It's the same rules.
Okay, sir.
Okay. So these are the three equations that we're going to use for vertical velocity only, and you should always remember that, right? Now I'll show you how it's done one by one, and I hope you will understand this. And when you're practicing it, you will have very less difficulty. So if you guys have written everything, should I please go forward?
So 1 minute.
Okay. Okay, Yaya, how are you? And Hamad,
Good.
how are you? Please try to come on time. Okay. And who else? Oh, I have greeted everybody. All right. Now, so now let's go to the next part. So first of all, we need to learn about certain basic concepts that I've talked about right now, and then we'll do different cases of each type of projectile, so you guys are familiar with what kind of question they're going to give you. So, for example, in this question, it says a projectile is launched at point O, and the path it follows is OP, blah, 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 blah. Air resistance is neglected. Great. Which statement is true for a projectile when it is at the highest point Q? The horizontal component of the projectile acceleration is zero. There is no acceleration. There is no acceleration in horizontal direction. All right, so you guys need to remember that always. So this is wrong. The horizontal component of the projectile velocity is zero. Again, it is always constant at each point, right? Okay, I mix them up. Okay, so that is also wrong. The kinetic energy of the projectile, this is what I'm talking about. Nope, because horizontal component is there. All right, so it can't be zero. And the momentum of the projectile is zero. What? What? The momentum of the projectile, that is wrong. No, it it has resultant velocity. Okay.
Sir, B
Now
is the
why?
answer.
No, it is A because I've written the same thing basically. All right, is that clear?
Yes.
The reason is why A is the correct answer because the horizontal component of projectile acceleration is always zero. Why? because it is always constant. So there has no acceleration. That's what I've written there. Is that clear, everyone? Any questions, please? Please write these comments with your question because they will help you when you revise this. They are concepts that you should know. Okay. Now, going to the next question. Now, it says in absence of air, oh my goodness. Oh my goodness. I messed it up. Oh no, I messed it up. That's sad. Damn, that sucks. Chalo, koi nahi. In an absence of air resistance, stone is thrown from P and follows a parabolic path in which the highest point reaches T. The stone reaches point Q just before landing. The vertical component of acceleration of the stone is the vertical component of acceleration of stone is 0 at T. It's talking about the acceleration of the stone. It cannot be 0. It is always 9.81. All right, or depends on G, wherever it is known. So always G. So the greatest at T, no, it is always constant. And greatest at Q, no, same always. Same as Q and T, and that is correct. Is that clear, everyone? So it doesn't change, it's always down no matter where it is, and it has the same value. Anyway, then comes this one. It says a stone is thrown upwards and follows a curved path. Why does the path have this shape? It has this shape because the stone has a constant horizontal velocity and constant vertical acceleration. Yes. Well, that should be the correct answer. But anyway, the stone has constant horizontal acceleration and constant vertical velocity. That's wrong. The stone has constant upward acceleration. There is no upward acceleration. The stone has constant upward velocity followed by constant downward velocity. That's wrong. It keeps on changing on vertical. Is that clear, everyone? Any questions now? Cool. Then a golf ball is hit with the same force in the direction of Earth on the moon, and which diagram represents the shape of diagonal ball? First of all, obviously, on the moon, if the force is more, because moon has less gravitational pull, so obviously the moon will have a greater, range that can go to. So either this, or this is correct. This isn't correct. Why? Because eventually moon does have some gravitational field strength, so it should come here. Now, why this is wrong? Because moon does not have air resistance, which doesn't slow down the speed of the stone horizontally. So that would be wrong. So I'm going to write moon has no air resistance. All right. So that's why it is this. So ideally, then we'll come up with this one and this one. This is absolutely wrong because if you look at the initial speeds, so both initial velocities are different, and obviously this cannot happen. Also, it's skewed, so that's not possible. And obviously, C is correct because on the moon there's no atmosphere, so it will follow the path like a normal projectile. But on Earth, it would be slowed down by air resistance. So this is the type of shape. If you expect air resistance, then it will be there. All right. Any questions, please let me know. Both Khatijas, Javerias, and Laiba, Maham, Ali, Sultanat, Sohail. Aman,
It's there,
Ayan,
sir.
Ahmed, and Umar, Wasam, Yaya, Zan. Okay, cool.
No question.
No, sir.
Okay, pretty bad. Hmm. Okay, now let's go to case one. I hope your concepts are clear about the basic ones. So, first question is when something will be thrown horizontally. This question will be there 70% of the time. So, whenever you see this word, you should be very, very careful because then it has certain things that you should know. A motorcycle stunt rider is moving horizontally. So, you move and you know what to do. In any case, when something is horizontal, you should always remember that initial vertical velocity has to be zero. That is the thing you should remember. Now, so what do we need? We need to know what is the speed of takeoff, which means he's asking about the horizontal velocity, which is ux. Now, if I want to find ux, then I would write what I need for horizontal things. I need horizontal velocity. That's what I need, right? So I'm gonna write UX. Uh, I need displacement horizontal, which is 10, and I need time. Time is not given, right? Neither I have time nor this, so I cannot use horizontal. So what do I need to do? I need to find time somehow. And if I want to find time, then I can use the vertical to do that. So I'm going to write SUVAT. The vertical displacement is 1.25. It is going to go down. So initial velocity is zero because it was thrown off horizontally. The final velocity is not given. The acceleration will be 9.81 and positive. Why positive? Because it is going down in the same direction acceleration due to gravity, and I can find time from here. And the best equation would be S equals to UT plus half AT squared. So this is going to be 1.25. This is going to be 0 times half. This is going to be 9.81 and T squared. Can somebody please find T for me?
0.5.
0.5 seconds. Very good. So I can use this time right here, and the only equation for horizontal is velocity is equal to displacement over time. I want to find ux, displacement is 10, and time is 0.5. So what is the answer then? 20.
20.
20.
So this is this easy if you just follow what I do. I just take out, I make sure that I treat horizontal, everything horizontal separately and everything vertical separately. Now, going to the full projectile question. Now, in those questions, never ever get scared by looking at the answers because they will help you. First of all, we see we have to make two components, one horizontal, one vertical. We should remember that this is v cosine of alpha and v sine of alpha because it is next to the angle and that is away from the angle. We have the maximum height as h and we want to find that. Now, first of all, I would like to make horizontal and vertical. You know, where I need to fill up the information that I have. Velocity, displacement, time, and in this one, SUVAT. I do have horizontal velocity, which is v cosine of alpha. I have the displacement. No, I do not have the displacement. I do have the time. Let's keep it time as t. And the displacement vertical is h, and now it's going up. So initial velocity will be v sine of alpha. And at the highest point, we should remember the vertical velocity is zero, so it has to be 0.5. So this value is going up and acceleration is down, and this is t. All right. So first of all, if I want to, correctly do it, obviously I need to include h. So I'm gonna use equals to ut plus half at squared because I do not have final velocity. And s is h. This is v sine of alpha times t plus half minus g and t squared. Okay, so this will become V sine of alpha t and minus half gt squared. Now, what do I need to do? I need to make, I have this, but if I notice, there is no time in this. There is no t. So I need to replace that somehow. All right. So what I can do is, I know for this one, the only equation is velocity is equal to displacement over time. Velocity will be v cosine of alpha. And this will be, displacement is going to be, I don't know, have that. Let's call this. Do I have that? Do I have that? I don't have that. That's not fair. Okay. Well, that's not fair at all. Okay, never mind.
Sir,
Never
why
mind.
don't we use 2s is equals to v square minus u square?
Yes, sir.
If we do that, oh yeah, we can do that. Sorry. Yeah, we do not have this, so that would be better actually. Because I have to then do it long way. All right, let's do that. So if I use that, then 2 times minus g, displacement is h. You are so right about this. 0 squared minus v sine alpha whole square. So this is going to be 2gh equals to wow v square sine alpha square. And this cancels out. H is v square sine alpha square over 2g. And
See.
that is c. Very nice. Okay, we do not need to go there. All right, very nice. Cool, cool, cool. All right. Then we gotta go towards, okay, you guys can copy this and then we're gonna go forward. Today we have a lot of time actually. All right, wait. I think tomorrow we are gonna start with probably momentum. And I made a big, big mistake today. If you can't access the old lectures, okay, do let me know. Because probably I deleted them by mistake from my drive.
Sir, have you uploaded the sheet for momentum?
Not yet. It will be uploaded tonight. Basically, my Google account said you are not allowed to get more than 100 GB. I said, okay. And the Google account said, you want to, reset everything? I said, yeah. And then it deleted all my
You can
files.
simply upload it on the Google Classroom.
Yeah, I have to upload it now again. No, the Google Classroom uses my drive as well to save every information. All right. Anyway, doesn't matter. I have the backup. I will get it. So, then let's go and let's do the next one. So half project done. Now this one is very simple. Again, it says what are the horizontal displacement x and basically displacement y after time t, which is pretty easy. Again, you need to fill up the information. This is v, and this is, sorry, v sine theta. This is v cosine theta. So we need v st. So this is v cosine theta. This is x, and this is t. SUVAT. The horizontal displacement is y. Initial velocity v sine theta. And final velocity is, we don't know this, by the way. The reason we don't know this because it doesn't say if it's at the highest displacement or not. So we're gonna use this as minus g and time as t. This time we're gonna use y equals to v sine theta times t. Okay, I need to explain it in detail. Sorry. S equals to ut plus half at squared because there are t's in here, so that's fine. Y equals to v sine theta times t minus half g t squared. Okay, like that. And this one is going to be v is equal to displacement over time. So then what you get,
Sir,
v
y
goes,
minus. You in the equation you wrote plus half, and then in the
I put
oh my
minus
bad,
g, that's why. Suhail,
my bad, my
oh,
bad.
over t. So now x is going to be vt cos theta, which is this one or this one. And y is going to be vt sine theta minus half gt squared, which is b. All right, is that clear now?
No, sir, I didn't get the vertical one.
You didn't get it? Why?
Sir,
Okay, so you see this. The vertical displacement is y, right? You agree? You agree?
yes, sir.
The initial velocity is v sine theta. You agree? Now,
Yes,
in
sir.
the question, they have said nothing about y being the highest displacement. Have they said it?
No.
So it means v is not known. We don't know that. Do you understand?
Yes,
If this velocity is upwards, g is down. So if automatically we take it as plus, we have to take it negative, right? So we have to put a negative g here. You agree?
yes, yes, sir.
And then time would be the same time when time t when it reaches here and time t when it goes up, right? So
Yes,
just use s equals to ut plus half at squared. This will be y. This will be v sine theta times t plus half minus g and t squared. So y will be v sine theta vt sine theta minus half gt squared. You understand?
yes.
Okay, good. All right. Any other person who has still difficulty in understanding? Please let me know. Okay. Now, so this question is a very important question. And sometimes he's gonna ask you the resultant displacement at a particular time. All right. So if this comes, then you don't have to worry. You just need to use Pythagoras theorem. Like for example, it says at certain time the projectile horizontal velocity is this and vertical velocity is this. What is the speed at this projectile? Which means he's asking about the resultant velocity here. Do you guys understand this? In any question or any part, if he does that, you just need to use Pythagoras theorem. And that would be v equals to 10.1 whole square plus 23 whole square root of the answer. All right, can you please find this?
See,
So it has to be C. So it's pretty simple. Do not worry about that. You just need to use the same vector rules that we have done already. Okay. Now in this chapter, I have basically put in a lot of mixed questions. Okay. So I believe you will be able to do it. But
Sir,
first
wait,
of
I
all,
need to write.
yeah, okay. It should be mixed. Okay. Okay.
so today class they will finish kinematics, right?
Yeah, we are going to finish it today. Tomorrow we are going to start dynamics. Anyway, so this again, question number 4 is for you to practice. And if you look at it, it says thrown horizontally. Do you guys know what that means? Who can tell me what that means?
Initial velocity 0,
What initial velocity? Initial
vertical.
Vertical.
vertical. Very good. Excellent. Now you should know you will be able to do the entire question on your own. This is very simple. And this last one is the same as this one. So please refer back to this. You will be able to do this. Anyway, I want to do this question. I love this question. So I'm going to do this. So first of all, it says a small ball is thrown horizontally. So automatically I should understand that the initial horizontal velocity is this one. This is ux. And the vertical velocity uy has to be 0. Okay. So now it says state the magnitude of horizontal component of its velocity when it hits the plate. Do you guys know what the velocity would be?
To stay the
It stays the same. Excellent. So you're gonna write 4.0. Then show the vertical velocity. Now I'm gonna use, because he's asking about vertical component, so I'm gonna use SUVAT. The displacement vertical is 1.96. The initial velocity is 0 because it was thrown horizontally. The final velocity I gotta find, and that's what I need. Acceleration, should I take it positive or negative? Who's gonna tell me?
Positive.
Positive.
Positive,
And the reason is?
because it's falling downwards.
Because the velocity is moving that side.
Yes, so velocity and acceleration are in the similar direction. Okay, so and time is not given, so we're not going to take that. We're going to use 2as equals to v square minus u square. 2 times 9.81, displacement is 1.96. This is v squared, this is 0 squared. So what you get? Obviously 6.2. Yes, okay. You guys understand this? It's pretty easy, right? And that's only for 1 mark. That's not fair. All right. Never mind. Now it says the component velocity in both vectors complete and draw to scale. Now this sort of question, obviously, when it comes in the exam, the biggest issue with this is that they have already given on the actual paper there will be a scale, right? But right now, I don't know. What I'm going to do is I'm going to try making a scale, okay? Let's try that. So in the exam, what you're going to do is you want to measure this, okay? You want to say, okay, this on my scale right now is about 3.9. Okay, so I'm gonna say it is 3.9. In the actual paper it was basically 4 centimeter. Okay, but 3.9 centimeter is equivalent to 4.0 meters per second. That was the horizontal one. Do you guys agree? Like that. Then either you want to make a vector triangle or a parallelogram. That's entirely up to you. But right now what we're going to do is we're going to make a vector triangle. So if I want to do 6.2, right, the vertical velocity, so I would say if 3.9 centimeter represents 4 meters per second, then 6.2 meters per second would be what? I'm going to cross multiply that, and then it's going to be 3.9 times 6.2 divided by 4.0. Can you please tell me what would be the answer?
0.045.
Sorry?
6.045.
So it's basically around 6, right? 6 point, I don't know, 6 point. Okay, so then here you're gonna take 1, 2, 3, 4, 5, and 6, and then just, connect the tail with the head, and then you're gonna get this one. This is basically 6.2 meters per second. And then from this end where we started the drawing and ended, we are gonna draw the resultant. Those who have joined late, and if you want to revisit this, please do watch the recording. And if you still have any questions, do refer back to me. Anyway, so then from start to end, we're gonna draw the resultant, and we're gonna measure the resultant then. So if you measure, so it's gonna be 1, 2, 3, 4, 5, 6, 7, 8, 6.1, 2, 3, 4, 5, 6, 7. So this is basically 6.7 centimeter. Okay, so then I'm going to say if 3.9 centimeter was 4, then 6.7 centimeter will be x. Cross multiply, please. What you get?
6.87.
6.87 meters per second. So that should be your answer. And what is to the vertical? So we want to find this angle. And to do that, you put your protractor here and then turn it. So my protractor shows that it is around 65, 64. 90 minus 64 is what?
26.
So it's 26 degrees. Is that clear, everyone?
Yeah.
Okay, now let's copy this important detail and let's put it back. Okay. All right. So now we got it.
So can you go for a moment?
Sorry?
Could you go up for a moment?
Yes, please. Why not? Obviously, if you like to draw parallelogram, you can do that. But if you attempt to solve this question with any analytical method, whether it's vector triangle or resolution, you will get no credit. So that's why I'm saying you have to learn all methods because they can fix you on anyone. All right? Done? Should I go forward now?
Yes.
Okay. Then it says after bouncing, the ball rises to a vertical height of this much. Calculate the vertical component velocity of the ball as it leaves. Again, we want to find the vertical velocity. We want to find SUVAT. The vertical displacement is 0.98 and that is 0.98. The initial velocity, now there will be an initial velocity because it will be like this, horizontal will be like this. But because it reaches highest velocity, the final highest displacement, the final velocity will be 0. So final is 0. Acceleration, should I take minus 9.81 positive, please? Anyone?
Yes.
Yes.
Okay, I'm gonna take it negative because the reason I
Yeah.
want to take it negative is because now I'm going up and the acceleration is still down. Okay, like that. And the time is not given at all. So just use 2s like this. So 2 times minus 9.81. Displacement is 0.98. Final velocity is 0 square minus initial velocity is, that's what we are looking for. Can you find, please? You.
4.38.
Okay. What'd you get?
4.38.
Okay. Okay, that's our answer then. All right. Everybody understands this? Any questions?
No, sir.
So it's pretty easy as long as you guys understand when to do what. Okay, this
Yes.
question is your homework then. This is half projectile. It's the similar one that we've done before. And these are some questions that I want to discuss with you, okay? These are some exceptional questions. And obviously, they are pretty darn difficult. Okay, so first of all, let's see what's happening here. So there's one guy who's jumping off a ramp, sort of edge, and then he goes into a projectile motion. It says ignoring a resistance, which graph is best represents the variation of speed v with the horizontal displacement. So his speed v means that it's talking about the resultant velocity. All right. So when he's at this speed, so obviously his resultant velocity is going to be here, right? Which means the graph must start from a certain velocity. All of the graphs start from a certain velocity. and that's absolutely all right. Do you guys know why C would not be the correct answer just by looking at it?
Because at a point,
Yes.
velocity becomes zero before hitting Q.
But then it should be correct then, according to your logic. Why am I saying it's wrong when it shows clearly that at point velocity is zero?
Because there is always a horizontal velocity.
There's always a horizontal velocity, so the resultant can never be zero, which means that this is entirely wrong. Then, if that is the case, as the displacement is increasing, should the velocity, now if you look at it, the other graphs, if you notice, they're showing us a sort of connection, which means it's showing us a downward curve. So it's showing that velocity increases, the resultant velocity increases to the top, and then it starts to reduce. Is it possible that if the vertical component of the velocity is reducing slowly each time, and here vertical velocity is zero, can the velocity really increase? Yes, people of this world. Can the velocity increase? Like, would the velocity, the vertical the resultant velocity, be highest at this point? Can it happen?
Mister, repeat, please.
I'm saying that in graph A, it's showing
Sir, can you
that
repeat the
at the highest point, the velocity is the maximum, the value of resultant velocity. Is it possible?
no, sir.
No.
Why? Why?
Because vertical component is decreasing.
Yes, well, the vertical component is decreasing. So at highest point, overall velocity will be minimum, not zero. All right. So that means that this answer is absolutely wrong. Do you guys understand this? Now we get down to these two questions. And my idea is this is talking about displacement and the velocity. Okay, the horizontal displacement and velocity. Now, what we should understand is that as the displacement is going to increase, we can see the velocity is decreasing to the maximum point, and then it is increasing linearly. In here, velocity is decreasing and it is increasing linearly. Both are basically similar graphs. Only this graph shows that the acceleration is like the acceleration overall was somehow like not constant. Now, why am I saying this? To know this, you need to do a bit of working, but for this time only. For future, when I do this, you will not have to do this working. You need to understand that horizontal one will be the horizontal velocity. Let's write it ux, and displacement is x, and time is t. For vertical, it is suvat. So this is not given to us, so we don't know this. The initial velocity is basically some uy. Final velocity is vy. Acceleration is g, obviously negative, and time is t. Now, the relationship between this is v equals to u plus at, right? And the issue with this is that actually, when you relate ux, the velocity component of u and v, you should understand that they are squared and they are added at each point to give you the resultant velocity. Do you guys understand this? And now, this resultant velocity does not have a linear relationship with this displacement x. So it means the only answer that makes sense is D and not B, because it shows that V and X have linear relationships, which is not possible because the V depends on vertical as well as horizontal, which are squared at every moment. Is that clear, everyone?
Yeah, sir. Can you repeat this? I don't get it.
Yes. Okay, going to write this. Why I selected this? Because resultant velocity, resultant velocity and horizontal displacement, right, does not have a linear relationship. Is it clear?
Yes.
So why is that? Because basically this stays constant. That's correct. But then this keeps on changing, and there's a square in a root that doesn't make it a linear relationship. In linear relationship, it should be y equals to mx or y equals to minus mx, something like that. Is that clear?
Yes, sir.
Which clearly shows that that should not be the answer. So this is just a difficult question that you need to think about and apply reasoning to this when required. All right. Any question now? Let me know, please. Okay. All right. Yaya, sorry, Yaya is in this class, right? Yes. Okay. All right. Everybody understands this? Okay. Let's go forward then. Now, in this question, it says a double-edged launching device fires two identical steel balls. Exactly, balls x and y exactly at the same time. The diagram shows the initial velocity of the ball. They are both launched horizontally. If they're both launched horizontally, what do you say would be the vertical velocity initially?
0.
Okay, vertical velocity has to be 0. Now, it says which statement explain what an observer would see. Both x and y reach the ground simultaneously. Okay, because a resistance will cause both to have same final speed. That is not correct. The reason is the air resistance. Okay, let me think. Wait a second. The air resistance would basically the identical ball, so it has nothing to do with that. And if there was air resistance, then obviously it would affect the fall of both. X would basically has less velocity, so it would be nearer. Y would fall further away. But the thing is that both x and y reach the ground simultaneously. That is 100% correct, because if the initial velocity is 0, vertical, the only thing that is going to accelerate them downwards is g, and both of them have the same acceleration due to gravity. That would take them the same time basically to reach the ground, right? Because it is independent of the horizontal velocity. Because the gravitational acceleration is same, so this should be the answer. X reaches the ground before Y. That is absolutely wrong, because G is same for both. They have the same initial velocity, so they will take the same amount of time to reach. And Y reaches the ground. This is also wrong. Is that clear, everyone?
Sir, but it says that y has a greater speed.
It is released horizontally as the greatest speed. Now, again, come back to what I've told you. Horizontal velocity has no effect on how high or low it goes. Do you understand? It only affects how far it goes. So the horizontal displacement is dependent on this velocity, not the vertical one. The height is the same, so it will take the same amount of time to fall down. But this will fall further away. This will basically go like less horizontal distance. Do you understand? So do not mix both of them. They're both different things. Okay? Got it? All right. Any other questions, please? Go
No.
ahead. Okay. So remember this, keep both horizontal and vertical separate from each other, both in terms of distance, in terms of basically velocities, in terms of acceleration. The only thing that is common for them is time. So if one falls down, in, let's say, 2 seconds, the other will also fall down in 2 seconds. It has nothing to do with their horizontal speeds. Okay, understood? Well, I
Yeah.
clearly do not know who's Ibrahim, but anyway, who are you, Ibrahim? Okay, then in this question, it says a football is released above a plane, sloping surface, and bounces several times. The diagram shows the path between its bounces at x and y. Which graph correctly shows the variation of the horizontal component of velocity of v? Can somebody please tell me? What will happen to the horizontal velocity in any case? Please tell me.
It
It
will stay the
remains
same.
constant.
C.
Yes, it doesn't change. Why? Because only vertical changes and it's falling down. It is going down. So even the gravitational potential energy is going in the vertical velocity. It's not going in the horizontal component of the velocity. Everybody agrees to this? Good. Now, going to this one.
Sir,
It says a project.
can go.
Yes.
If it's sloping, then how is it going horizontal? How would we say it's going horizontal and the velocity will remain same?
Because the thing is, you need to understand something very important here. The slope is basically this way, right? You agree? The slope is decreasing vertically. You get my point?
Yeah.
If the displacement is vertical, then obviously the vertical velocity is going to increase because gravitational potential energy is changing to kinetic, and that in the vertical direction, not the horizontal one. Do you understand? There is no gravitational potential energy in the horizontal direction. Is it clear?
Yeah, sir.
Okay. So vertical means vertical, horizontal means horizontal. Always remember this. Now, this graph. It says a projectile is launched at an angle to horizontal when time is zero. It travels over horizontal ground, whatever. Which graph best shows the variation with time t of the speed of projectile when it is launched and when it lands? Who's going to tell me that?
C.
Exactly. Very good. It's C. And not A because obviously vertical velocity is going to change, not B. It's never going to be zero, never going to be zero. Is that clear, everyone? Good. Now you guys understand everything. This
Sir,
question,
wait, can go.
yes, please.
Sir, does the graph show vertical or horizontal value separately? How does it show vertical value?
It's not a separate graph, it's the resultant velocity graph. Okay. Like in one of the questions previously, I told you that vertical velocity doesn't, basically horizontal velocity doesn't change. So even if vertical velocity becomes zero at one point, then there is still horizontal velocity. So these two graphs are automatically wrong. Do you understand?
Yes, I get it.
In this one, it shows the speed stays constant. It doesn't stay constant because the vertical is changing. So only this one shows. Okay, good. Now this
Yes, sir, I
question,
get it.
uh, by the way, the rest of the questions you guys can do. I just wanted to draw, you guys can do this one as homework. And obviously this one is homework. I just want to show you the graph of the last one that I'm going to draw. I just want to tell you that because the acceleration due to gravity is constant and the vertical velocity is basically v sine theta or 60. So initially it is maximum and it reaches at this point. So this is the point where the time is 0.6 seconds because the velocity, vertical velocity is zero. This is a vertical velocity. And if they ask you like to complete this, all you need to do is you need to basically carry the line forward. Okay. Just carry the line forward. And that would give you, I don't know, time till time. I don't know what it says. Calculate time till it reaches B. So if this is like 0.6, so you have to make sure that you go till 1.2. And obviously it is going to keep on going. You have to draw it like this. Is that clear, everyone?
Yes, sir.
Yeah. Okay. This software sucks, so I just need to draw a straight line to here. Please draw a straight line. Okay, never mind. So you just need to draw this line. I just want to tell you, this is how vertical velocity changes. And if they say, all right, draw horizontal velocity at any point, so horizontal velocity will be a constant line like this. All right, everybody understand this? Okay. So this would be all. I am going to put this PDF on the Google Classroom. Please do not attempt to solve my PDF, which is like your PDF should be solved by your own hand, the full PDF. Do not solve my PDF, please. Okay, that would not be good. I want you to write the notes in your own handwriting so you remember. Okay, where am I going?